I will start with the PowerPoint, then I'll move to the demo portion. Okay, so my name is Boudewijn Aasman. I work at the Center for Health Data Innovations at Montefiore, and I'll be talking about integrating Atlas cohorts with DICOM images and ECG waveforms to enrich real-world evidence research. So what we've been working at CHDI, the Center for Health Data Innovations, is to build an integrated workflow to extract external data sources into a secure enclave, all run through Atlas. So right now we're supporting a couple different data types that are capable of being extracted to a secure enclave. These are the ones that have been requested so far by various researchers at Montefiore. So we've been working with DICOM, ECG waveforms, clinical notes, and reports narratives, and then also patient-level data from the CDM itself. These artifacts, like DICOM images, waveform data, are then stored in a secure enclave. Right now, they are stored at a high-performance cluster that's managed by the university here at Montefiore. And this data is tightly integrated with our IRB management system and also controlled through Atlas, where we've built something into Atlas where users can tie a IRB to a particular cohort, which I'll show. So this is a very high-level overview of the workflow, but everything stems from Atlas. There are two components that we've built into Atlas. There's one, which is the Upload Cohort API, which allows a user to upload a set of MRNs with a cohort entry start date and exit date that will then act as a real cohort inside of Atlas. This is something that's very useful for researchers who already know the set of images and accessions that they want to work with, but the cohort itself is very hard to reproduce in Atlas. So they can upload their own image, their own set of MRNs that they want to extract the images for. And then we have the extraction API and UI inside of Atlas, which allows users to extract patient-level information in various formats directly within Atlas. So we have different pipelines. For example, there's a DICOM pipeline where a user can extract image procedures, and those image procedures are then linked to accession numbers in the PACS database that actually stores those images. And then we have data pipelines in the back and controlled through Daxter that then actually pull those images from the PACS database and push them to this secure enclave, which is our HPC. They push them to the file system. Users are not actually able to extract the images from the file system on the HPC, but they have all of the different analytical tools to their disposal, and they can use the GPU cluster and all types of environments that allows them to do machine learning on the ECG and DICOM data. The same type of pipeline exists for ECG, and then we also have a pipeline for clinical notes. This one is slightly different. We have a separate UI for managing cohorts and notes. And we actually had a different demo at the symposium that showcased this, this platform. But those also get stored in an Elasticsearch instance on the secure enclave. So in full disclosure, we are nearly done with integrating these pieces into Atlas. Right now, this is a service we've been providing to the university. But right now we're launching these pipelines manually for the various different teams like radiology and other teams. But very soon they'll be able to launch it directly from Atlas. What I'm showcasing here is actually a snapshot of our extraction UI that is almost identical to the current state of what our deployed production instance of Atlas looks like. So if you look at this image on the left, users can actually specify variables from various domains of data. One of those domains is imaging, but this is where they extract, different measurements, demographic variables, procedures, etc. But they can extract an image here, and those procedures are linked to accession numbers in the PACS database. Once a user is happy with the different variables that they've selected, it brings them to this next screen that allows them to select the IRB that they've chosen for this cohort. It shows whether or not they are able to see patient level information through this IRB. They can choose where to export the data to. Right now, it's only possible to send it to our HPC environment. And then they can choose whether or not they actually want to materialize the artifacts, which is the images themselves, or if they just want to see the patient level information and also retrieve the metadata regarding those imaging procedures. They're also able to choose whether or not they want identified or de-identified data. Within our pipelines, we actually modify the DICOM metadata and waveform metadata itself and remove the identifying information if one wants to de-identify it, and we then link that metadata to the cohort and the person, the cohort and the person ID as well. And then lastly, we have a lot of different Dagster pipelines in our backend that control a lot of these data pipelines. Dagster is very similar to Airflow, and they're waiting for events on Atlas. And these pipelines are the ones that actually retrieve the information from these external data sources that are not part of the OMAP CDM. They de-identify them and link them to the OMAP cohort and person IDs and pushes it to the enclaves. And finally, establish the permission based on the IRB that's been established inside of Atlas. So let me quickly show what this actually looks like in practice. So firstly, we have a separate tab for uploading a cohort where a user can upload a file that contains a set of MRNs or person IDs and an index start and end date. And that will then materialize as a cohort that they can work with inside of Atlas. I'm gonna look at a cohort I've created, which this cohort right here, pneumonia with repeat pneumonia for inpatient visits, people that have had pneumonia and then a repeat condition of pneumonia within a year. We have a separate tab for IRB that they can specify their IRB that allows them to see patient level information. In this case, I'm using an test exempt IRB that's only available to a couple select super users, but this is going to allow me to extract patient level information. So now I'm going to the cohort extraction and find this cohort and click on download cohort. And that brings up the UI from the snapshot that we were just looking at. I'm going to create a basket, which is a basket of variables. And I'm going to go through the different domains that contain the different variables that I'm interested in. As I was saying, we're almost done deploying this to production, but right now the imaging piece is not available yet. So in this case, I'll just select the demographic variable. Maybe I'll choose gender and year of birth, and I'll choose a random measurement. Let's choose a lab like A1C that they can then add to their list of variables. Select a time window for which they want to extract this data. For example, this will collect all A1C values within the start and end date. And then finally, they can choose to export this information, tie it to the IRB, and extract the identified or de-identified data set. I think that's it. I think I've probably hit my 10 minutes. So thank you very much.
Thank you, Boudewijn. You didn't fully hit 10 minutes, so we do have some time for a couple questions. Paul?
Yeah, Boudewijn, thank you so much for presenting this. This is a great part of the multimodal vision for OHDSI. I like how you're using the OHDSI data model to then help define your cohorts, then kick off a pipeline. Was the pipeline specific? Would I like, if I wanted to say I want to get the MRs from today and from a year ago for the head, I want to do subtraction, can I build custom pipelines with this type of environment?
Right now, all of the pipelines are built by us. So can you maybe specify what type of pipeline you would be envisioning for what you would want to extract?
Cohort of patients with multiple sclerosis who've had HEM MRs for you usually get it on a yearly basis. I'd like to do a registration and maybe subtraction of the segmentation of their brain. Would be a typical pipeline that we'd be looking at, looking for like a relapse or a white lesion load.
Yes, no, that is absolutely possible. Yeah, that is absolutely possible. Right now, it is already possible for the notes, and that's what we showed in one of our separate demo. But we are linking those cohorts directly to the accession numbers.
Yeah, and how you said you're directly linking the procedure occurrence to the accession numbers. How are you doing that?
So right now we're using the source value in the procedure table.
So in the procedure table for procedure occurrences for CT, the MR, you'll have a list of one or many accession numbers that might be that imaging procedure.
Exactly.
And so it could be multiple accession numbers, right? Because you could have like a CT PET that might have two imaging modalities.
Exactly. We would have multiple entries in the table. Yeah.
Okay.